Next is another subject that is swirling about in the industry. And that's really the misapplication, actually generating a lot of malpractice from what I can tell. It's all about Kanban and project delivery and how it gets hijacked by schedule-based thinking. Our speaker is another expert in his field that needs a little introduction. James Chu is the Chief Technical Officer of Strategic Project Solutions and a member of the Technical Committee of PPI. He's been leading research and development of project production management and underlying framework of operations science, knowledge, process, systems for some time. So, James, I'm going to turn it over to you, and you're going to demystify some of these things for us.
Let's see what I can do. Can you see the screen?
Looks great.
All right, thank you. So one of the things that prompted us to actually look at this is while we're actually out there working with people, organizations, whether we're actually working in construction industry and for data centers or industrial or even in the general building sector, we're seeing a lot of use of the word Kanban and a lot of different implementations. Some of the things that we actually hear are statements like this. So, as I said, various implementation, not only physical, but also digital. Now, if you actually search for Kanban software, you're going to actually see 10, 20 different variations of those. Things that we actually hear out there are a Kanban board is used to visualize what work needs to be done and reviewed in weekly meetings. Another thing that we hear is our project is implementing just in time since we have scheduled our materials to arrive close to when we need to install them. Now, why are we talking about it just in time? Well, the topic is Kanban. We'll get to that relationship shortly. Kanban board is used to limit work in process. So there is some concept of limiting work in process, but really without guidance to how to determine the limits. So if you can figure it out, we have the capability to limit it, but again, without proper guidance on how to actually limit those limits. So what we would like to do is go through this topic of what Kanban actually is, why the industry is actually looking at it a little bit different, why we believe that's actually happening. How can we actually figure out most effective way to implement Kanban, and what does it look like in a project environment? So those are 4 questions I think that we're going to try to answer in this discussion. So what is Kanban? And I'm sure many of you actually have seen the translation of signboard, a visual board, or stuff like that, right? So the first word kan actually is to see, watch, and observe. That's the term. Van actually is the wooden board. So it's the visual board is the literal translation. However, if you start looking at the Toyota's actual documentation, it starts to actually define what Kanban is and what it was intended for in the original vision. So number one, it actually, just building on what Mark actually has already talked about, seeing lean from the perspective of operation science. The way that Toyota states it is just in time and jidoka are the 2 main pillars of the Toyota production system. Okay, so there it actually states those are the 2 main pillars. From there, it starts to say a number of methods to realize just-in-time production was devised by Toyota. One of the most copied is the Kanban. Again, this document was actually created in the mid-'80s, and it's already started that one of the most copied actually is Kanban. Now you can actually read the following in the paper when it actually comes out, but it's actually the Kanban is a way to actually realize just in time. What is just in time? Just in time is producing the right parts at the right time in the right amount. The purpose is to keep the stock to a minimum, right? And eliminating the need for warehouse, resulting in tremendous saving and overhead carrying cost. What Gary actually talked about, what the Western world actually has called the waste, right? So the purpose of the Kanban is to implement just in time so that the right products are produced at the right time, the right amount, in order to keep the stock to a minimum. So let's actually think about that and that where it actually originally came in. Well, how is it used now? So this actually is this year's from website. if you actually look at the Toyota production system, and we actually happened to see this in live when it was visited one of the plants, is the actual production is actually happening on a tack, on a conveyor belt going down the line. And as things are progressing, there is the parts retrieval Kanban. Some books actually call this conveyance Kanban, which actually says if you actually have the stock level get to a certain point, bring more on next to the conveyor belt. And if your stock level runs below a certain level, then start making certain amount. So there is always a limitation of WIP in here and the limitation of WIP in here. Again, this could be one rope here, and there's another actually here. Replacements of parts used are only those that have been used, as well as the production, again, is producing and replenishing only those parts that actually have been retrieved. Okay, so again, there's the concept of limiting the WIP in the system and using Kanbans as the means to do so. Okay, so what's really, really interesting is if you actually study the word just in time, that time is really not about time. That time is about inventory policies rather than dates and time. So one of the things that we actually take for, maybe it's just the interpretation, is just in time. We try to actually schedule something to actually happen in just in time. We actually try to actually say, at this time, something will actually happen. But the actual concept is not about time. Okay. So, however, what does the actual implementation of Kanban in project delivery look like? And I'm going to actually show you two representations are very common that we actually see. One is that there are Kanban boards for visualization of work, and it actually takes a form of something like this. There is something work that needs to be done. It's in progress. It's ready to be deployed. It's actually being approved, and it's actually done. So the work is moving through this process. Again, there might be, I've seen some versions where it actually has a little bit more detail in the boxes and these either using post-it notes or virtual post-it notes or boxes that actually go through it. But it's actually showing progress of what actually is happening. Some actually have aggregated man hours written on the bottom and so forth, but it's mainly actually looking at progress. Some Kanban systems are about schedules. Okay, the Kanban boards. It actually shows Monday, Tuesday, Wednesday, and dates and the task that needs to be performed. Most of the Kanban boards, that digital boards that we actually see, are more than a week. So you might actually have 2 weeks, 3 week look ahead, actually represented in a post-it note, and it's actually used to say this is a Kanban board. So as you can see, the actual concept of limiting the WIP, and thereby, as Mark actually talked about, having the things move through the production system quickly, again, with the reduced cycle time, for having less actually cash tied up in the system while providing customers what they need with a shorter time frame, is really not captured in this mode. Whereas I think it actually becomes out of the traditional a conventional translation of what Kanban actually means. But I think that the reason is deeper. Okay, so what is actually driving the difference between the two perspectives? One is, as this is a diagram that I think you guys actually have seen many, many times already, is the project management is concerned with dates in progress and controlled most of the time with schedules. So if you look at project, some projects actually have integrated schedule where you actually have a project schedule for design, some for fabrication, maybe actually for procurement, delivery schedules, installation schedules, commissioning schedules, start schedules, and so forth. So those are all the separate schedules. Some try to actually integrate it into one system. But that actually is the means to trigger what actions need to happen. However, in reality, in a production management, it's actually measured in terms of the rates and throughput, as we actually have already discussed many times, and it's controlled by policies. And Kanban is actually a control policy where it actually says only make this much, only deliver this much. Okay. So the question now then becomes, how do we actually do that? How do we actually set the inventory, which means work in process and stocks for production control, including Kanban? There actually is a lot of discussion in the lean world about push versus pull versus conweb, right? All those are different production control policies. But the only one that we actually know controls WIP is pull, and conweb. So we're going to actually use those science to actually talk about how do we actually set the policies and how do we control it. Okay. So operational science is going to actually help us answer the two questions that are necessary to implement Kanban. One, how much work in process is required to meet the demand with the minimum cycle time? Okay. And what are the stock policies required to meet the required fill rate with minimal investment? Well, if you can answer those two questions, then you can actually use either it's a virtual Kanban or physical Kanban to implement the system so that you are actually controlling WIP and thereby minimizing cycle time and investment. Okay, so let's go to the next topic. Now, if you actually have worked with us and in the PPI world, you might actually have seen this diagram many times, but we're going to actually go through this a little bit to give you an indication of how do we design Kanban systems. So for any production system, again, this is actually not manufacturing environment, but this was pipe spools fabrication. So if you actually look at this, the actual throughput of any production system actually has a bottleneck where if you actually start to put more work in process into the system, your throughput will increase until you actually get to a point where you cannot do anymore because of the capacity of the system, maximum capacity of the system. And therefore, no matter how much more you put in, you're going to actually flat out. Cycle time stays the same, roll process time, until you actually get to a bottleneck, and then it's going to sit around waiting between stations. So it's actually going to go up. Okay. Again, very simple concept. What's really interesting is, as Mark talked about, when variability introduced, and variability is not uncertainty. Variability is not something unforeseen. Variability, regardless of where it comes from, as Mark said, it will degrade performance of the production system. So 4 things, such as having different variety of size of pipe, having different welding requirements, having different number of joints, having different size of nuclear reactors, as Tony talked about, is going to be the cause of variability that's going to start to degrade the system performance. And in this case, the throughput actually starts from here, come down here, and the cycle time from here starts to go up to here. Okay, so this is just one example. How much gap there is between these two lines are going to be a function of variability. Okay? We've seen some systems in the construction industry where they're very tight, and we actually seen some actually are very different between what could be possible with zero variability versus with variability. Okay. Now, why does this curve matter? Because this demand is what we need out of the system based on the schedule or the rate of the consumption or the tact. This is the rate of throughput we need from the system. Therefore, where these two intersect is the minimum width we need in the system. Okay. If we don't know what the width should be in the system, there is no control. Even Heijunka actually said, if there actually is no standard, there's no improvement. Okay. So again, we need to actually know what the width is. We actually, as I said here, this is the minimum width. Because the gradient actually here is sharply dropping afterwards, we might actually choose to say our optimal width is not 13.5, which is not a whole number. I'm going to actually choose my optimal width to be 15. That is what I want to control to. So if I actually was choose to 15, then what it actually is allowing us to do is to actually say, there's actually 15 is going to produce a cycle time of 8.72 days and a throughput of 1.72. Okay. So again, you can actually have determine what the optimal WIP you're going to actually have in the system actually is, and understand the total behavior, which is here's the throughput I'm going to get, and here's the cycle time I'm actually going to experience. So that's one part of the equation. The other part of the equation is the stock. We actually talked about things that are going to be manufactured or actually being bought and actually have ready to be replenished. So those are stocks. So how do we actually set the stock? And this happens to be an example of a study that we actually performed, optimization we actually performed for an organization. And what's interesting is you actually see three numbers, and I'm going to actually three dots here, and I'm going to explain what those are. So this one number right here that you actually see was predicted. So what we did is we actually took their current plan on how they were planning to buy and hold and manage the inventory. And what it came out to be is that the fill rate, expected fill rate was 80%. And the investment dollar that was actually going to be was 2.6. This was predicted. Now, we do know that anyone that's actually have managed inventory, that if you actually have more than you actually need, not many people complain. But if you don't actually have every time someone comes to find one and it's not there, people start complaining. So what actually starts happening? People are starting actually buying more and holding more than what the plan was. And this is what that number is, the actual. The actual performance was 94.62% with fill rate with a $12 million. Again, as you can see, the amount of money has actually increased tremendously, but this was to actually satisfy people saying, we can't run out of stuff. What this curve, again, calculated with operation science, is actually showing us that for the minimum amount of inventory investment for a given fill rate. So you can actually make a choice to say, I want to be here. That actually says I'm going to have that much cash tied up. If I'm actually down here, the 96%, 97% range, I'm actually going to have $5 million or $6 million actually tied up. So we chose one. We chose, you know what? Let's actually choose 97. That allows us to actually reduce $4 million. So we're actually 2/3 of the investment dollars that we actually have. At the same time, we're going to improve our fill rate from 80% to 97%. Again, 17% or 80%, 70.5% improvement in fill rate. So less money and better service. When we chose that, again, this actually consists of many, many items. You can actually see a lot of the stuff that used to actually have these poor fill rates are actually now having fill rate that's actually over 90%. Again, we can actually set the minimum threshold to actually be 85% or 80%, whatever we choose to be, or the organization chooses to be. And for each item, you're now starting to actually see reorder point and reorder quantity, okay? And safety stock or day supply, whichever system that you want to use. Reorder point and reorder quantity means if the number of items get to this number, order this much, order this much. If it gets down to this number, order this much. If it gets down to the number, order this much. So again, that starts now sounds more like a Kanban system. If the Kanban system actually starts dropping down, then get more. If it goes down to this number, get more. Again, how much you actually have to carry is based on what the lead time is for that item. Okay, and the lead time might be, if you're making something, it goes back to our question is what is the right amount of WIP that we need to have in the system, which is tied to your cycle time. Okay. So how do you actually implement these actually in a project environment? We're going to talk about two examples, just one example with two different, one for the WIP and one for the inventory, using the project that Tony actually talked about, the Heathrow Terminal 5 project. So this actually happens to be an example where the field is actually determining what is going to be actually happening on a week-to-week basis. So in a week out, you can actually say, these are the foundations that I'm going to be placing. That triggered the teams to produce the engineering information right here, teams to actually collaborate to produce the engineering information, create a full 3D model that are actually designed to part by part, that gets sent into the fabrication shop. The fabrication shop would cut and bend and assemble and actually have it ready to be sent. And in 2 days, and then it actually was installed within 2 days. So in here, this action of what's actually happening is actually triggering what goes into the system. So there is constant working process that's actually designed and controlled within here. Okay. Now, how do we know the system actually was controlling WIP? Because when the site rained out for 3 days, the fabrication shop stopped. Okay. In a traditional environment where it's a push system, if the site rained out for 3 days, the fabrication shop will still continue to produce. So again, this is an example of WIP control implemented into a project environment. And this is actually a very, very akin to a ConWeb system implemented in this project as well, where the actual site had all these bins laid to each other. Again, you can actually see the difference in the bins, matching the reorder points and reorder quantities. If one of the bin got empty, it would be actually placed outside. This bin would actually, the truck collecting these bins would go back to the supplier, have a similar bins actually on that side that we would collect and coming back, and it will be actually on a more of a ConWeb system, actually here, Mimax system, that's actually collecting and replenishing as people are actually using it over here. Again, was there a set schedule of when something would arrive or something would actually be replenished? No. It's whenever the stock levels actually got to a certain point, that's what actually happened automatically. Okay. So again, this is an example of WIP control implemented during the actual making of something, or actually an inventory or stock position that using Kanban system. Okay. So hopefully that actually clarifies what Kanban was intended to do, what its actual original intent is, how we can actually take that and not only provide visibility of what's actually going on, but also control the amount of inventory in the system that allows us to minimize cash tied up, as well as minimize cycle time. So we actually get our projects actually done when we actually need to get done, or actually even faster and cheaper than when we desire to do so.
Very enlightening. Maybe you could close your stop sharing so we can. There we go. You must have answered everybody's questions, because we don't have any pouring in here. Hey, what? You don't like my Kanban signs? And it's really interesting that it really doesn't have anything to do with boards in scheduling at all. And as as we visit project sites, you see that's really how it gets used a lot, is around boards and scheduling, and become part of the scheduling routine. Hey, one thing you said just cracked me up. You said you knew the system was working on the example with the rebar because when there was a rain out at the job site, production stopped.
Yep.
Just stop and think. Project people, if you're online here, stop and think about that for a minute. What would you do if you were running a fab shop and the site got rained out? Well, I'd turn up the crank and say, it's my chance to catch up. And I'd be producing more materials and trying to find some laydown area. I mean, that's the natural reaction, is to not throttle back and to not control the WIP, instead to accumulate it and to get more ready so that you're never waiting on anything. That is just really counterintuitive, but really, really important concept, because that accumulation of work in process means it's going to take longer ultimately to finish the project. Okay, so we got a good question here. When is a good or accurate indicator that we need to change our Kanban signal? If the current one that we have is not making us have improvements in the production system?
Well, need to actually better understand what means to what you're referring to as the Kanban signal. But if we actually go back to what we're actually talking about, let's actually say Kanban signal is the implementation of policy. And you actually say, this is what I actually expect in terms of cycle time and throughput from the system. And if that's not actually delivering, our system that we have implemented is not delivering to that numbers, then we need to understand whether we actually have misinterpreted the actual performance or capacity of the system, or we actually have chosen a number that is not going to be able to deliver based on the capacity of the system. So I think that's where we actually start to look at it. Is the system behaving the way we expect it to behave with the Kanban control that we have in place?
And if it's not, you adjust it and monitor and so you get that feedback loop coming, right?
Yeah.
So another question, are simple boards with Post-its useful in some situations?
Yeah, I think so. I think if you actually have Kanban board and, well, not Kanban boards, actually a simple board with Post-it notes have been successfully used to map processes. Again, I actually see more useful in mapping processes than mapping schedules. Because again, from a production perspective, we actually have, I've seen people put up Post-it notes and I've facilitated numerous of them in the past. And I'm actually going to do one tomorrow, is when we actually put up a Post-it note, we actually like to ask, how long would this actually operation take? And typically the response we hear from the participants is, when would you like to have it done? And when you start to get into that, when would you like to have it done versus how long does it take, you really don't have an opportunity to actually improve much when it actually is all about when would you like to actually have it done. Because the inherent process time, inherent capacity buffer or time buffer that's actually built in doesn't become obvious. It might be helpful, when you're actually saying, what are you promising me? But if you're actually into actually mapping the production system and optimizing, I would rather see that map or Post-it notes used to map the processes and the process times, and it's in a relationship rather than actually just schedules.
Yeah, very good. Well, with that, we're going to have to close it and move on to our next topic. Thank you, James, for that insightful sharing of your thoughts and the paper that's coming along with it. So thanks you in advance for that.
Thank you.
All right.